Okay, so restart recording.
Empty all the water. Yeah. It's not harvesting, it is managing.
Yes.
Rainwater. What is it?
Results were
Results were. Okay.
Yeah, we've tried that Hollywood type letters on the top just to make it very
Bollywood.
Hollywood.
Maybe Bollywood.
Maybe.
Maybe we'll start with the presentation and we will switch from the presentation to the demo because we have chronologically timed the demo and it will go well. So my name is Salman, this is Sanjeeva, Arnab and Niroshan, and we are team 17 and our project is the rainwater management system, and we hope to explain motivation and the reason we did this system as well as show you what the system entails. So the first thing you might notice is that the prototype is actually bigger than the size specified. We would like to mention this in the beginning because we are using water. So water, we need to have some sort of height for the gravity, for the water to flow, because if you keep a lower height then the water wouldn't flow. So that's our only reason for making the prototype bigger. But I mean, that's
You could have done something, you could have reduced this, and when it is operational, it is going up.
No, springing system. So let me just explain the problem we have tried to address first. We see that around the world there is so much of water. Water is the primary component of the world. But however, we waste water too much. So as you see in some of the pictures, people just waste water, take water for granted, and leave taps running and all that. So the idea of the system, as you see in the slogan, is that only 1% of our Earth's water is already drinkable. And from that 95% we are already wasting. So only 5% of 1% is what we can actually use. So our system focuses on the places where there is excess water already. For example, places with flash floods, places with freak storms, and places where people have to travel like this on the road almost every day. And these places can do well with our system. Basically, the idea can be summed up in 3 words. The problem is bad water management. And we are going to explain a solution which will try to reduce costs in a person's home and at the same time, manage their water better. So the solution to our system, we probably call it the Rainwater Management System, RWMS, which may be misinterpreted as Results World Sentosa. So the system works very simply. So there is a rain detection mechanism which will be sensed in the roof. Then after there is collection of water. So if there is rain, the lid will open, the water will be collecting. Then once the water is collected and at a certain time, the water is smartly allocated around the house according to the user's needs. Then, if the user needs the water to drink, the system senses that and purifies the water by heating it. Then there is an intuitive graphical LCD and touchscreen interface which you can use and manage your system through. And at night, every day the system will do an auto system maintenance to see if there is leaks, if there is something wrong with the system, and if there is, it will go into an automatic lockout. And we will demonstrate all these features in the next few minutes. So let me just highlight the full block diagram of our system. It may seem complicated, but I'll break it down into 4 subsystems and how we worked on it. So the first subsystem is called water and leak detection. This subsystem encompasses the rain sensor, where it detects when there is rain and opens the house lid for several specific cases. And it also encompasses the water level sensor and the pinch water valves to make the leak checking algorithm, which happens at night. The second subsystem is the water purification system, which detects if you are going to use the water for drinking, and if you are using the water for drinking, it will heat it and purify it. Then the third subsystem is the centralized GUI and the scheduler. As you see, there's a graphical LCD and a touchscreen which has a GUI interface, which is intuitive, and it works with a resistive touchscreen. And at the same time, there's a task scheduler inside which automatically allocates the water or automatically does the leak checking. So there's no need for the user to interfere at all. It's all automatically and scheduled. Also, there's a peak-to-peak communication, and we have created language for the 2 peaks to be talking to each other at all times so that they know what data is going across. And the fourth subsystem is the water allocation algorithm. This is the heart of our system, and it distributes water across the house in an efficient manner. And we will explain all this in detail. So to take over, I'll pass on to my colleague Sanjeeva, who will be explaining the water level sensors and the rain sensor and the house tank lid. And we will demonstrate to you.
Okay, the rain detection, the logic is very simple. Basically, we want the pit to be closed whenever it is not raining. This is there to prevent any water evaporation or something like that. So
guys, come here and see.
Okay, so my friend will simulate the rain on the water, the rain sensor, and then the lid will open.
So it will be like.
So now the tank will be filling up.
tank will be filling up.
And we also have another system to close the lid when the water reaches the maximum level. This is there to prevent any overflow. But in this case, we are just going to stop the rain. So when we stop the rain, when the rain stops, the lid will close.
Wow.
It reached maximum level, so it closed.
Now it's
don't worry.
all waterproof.
So the moment you remove it, it closes.
No, when the tank gets full,
When tank fills
not
up,
the,
yes,
if the tank if it drains, it won't now
How
open.
do you sense whether it is
There's levels.
there's
here.
level sensors in
We'll come to that. We'll come to that in a couple of slides.
Okay, so we're going to talk about the water level sensors next. Oh, this is when the rain falls, and yeah, when the rain finishes and it will close. And the next test is when it's raining and the tank fills up. It's still raining, but the lid will close because the tank is full now. We want to prevent any overflow. And okay, the water level sensor. This is a transistor-based detection system. It will have a the reference wire. So when the water fills up between the reference to the water level sensor, it will send an output, and we have a decoder. So what the decoder does is we have like five levels for the five levels, and we want to reduce the number of outputs that we're going to send to the PIC. So we use a decoder to convert the 5 levels into three bits.
you have 5 discrete points.
Yes. To indicate
5 wires
milliliters to 100 up to 500 milliliters.
What the transistor-based thing here?
We use a transistor. What it does is we have the sensor is connected to the base of the transistor, and we have the reference wire. So when it conducts when the water fills up to that level. So then the electricity will flow from the transistor, the emitter. So that will send the output to the decoder. So the decoder will make a decoded signal and send that to the PIC. So when there is no water, the decoded signal will be 000. So when we have water at the first level, which is 100 milliliters, the signal will be 001. And at 200 milliliters, it will be 010. And the full level will be 101.
You can check the full level, so it will be showing the.
As you can see in the graphical LCD here, it says 100%
graphical LCD.
Okay.
This decoded signal will be sent to both PICs. For the first PIC, using the graphical LCD to show you the water levels, and the second will use it for the water allocation. And we also need the water levels for the leak checking, which I think Salman will explain later, right? So this the water level sensor will be used by most of the functions, actually all of the functions in our system. So the signal will be sent to the microprocessors. And next we have the internal clock. So this is a timer 1 based interrupt. So this is there to simulate a real-time clock. It will always be running. So no matter what happens, it will always keep counting. And you can go to the scheduler screen on the graphical LCD to look at the time.
Touch screen?
Yeah,
Yes.
or touch.
Yeah.
So
So that will indicate the time. So, and this will decide when to start the functions. So at 6 in the morning, it will start the water allocation algorithm, and it will allocate the water. And then at 11:59 p.m., it will do the leak checking. And that's the timer. And I will pass to Niroshana to explain the water allocation algorithm.
okay, that's fine.
Yeah, just run it.
Okay, so water allocation, for the water allocation, basically the water flow is controlled by the pin valves. When the valve is open, the water will flow, and when the pinch valve is closed, the water will the water flow will be stopped. So for now, I'll just allocate. So because it will take about 8 minutes to allocate for the whole system, I'll just allocate. See here it's in allocation mode, and I select milliliter mode, and I select the location kitchen, and select.
So it should be done manually.
Yeah, you can allocate manually. Okay, I allocate 150. Then I okay. for laundry I allocate 100, and for drinking I allocate 50. Okay, yeah. Now I will just continue the presentation. Yeah. So in the water allocation there are like two control modes. One is percentage mode and milliliter mode. So the user can allocate in any mode he wants. So percentage mode is basically according to the it will detect the tank level, and whatever the percentage you give, it will allocate that amount of water. And milliliter mode is you can just select the volume you want, and it will allocate to that location. So, and for demo purpose, we have 3 distribution location: kitchen, laundry, and drinking. And for the drinking location, the water will be purified and sent. So basically, how the volume is calculated is there's a counter tank here which has a 10 milliliter level and a 50 milliliter level. So it will read the levels and the user input, and it will calculate the number of loops this counter tank must run, and it will allocate the water according to that. And the limitation is it only counts 50 milliliter and 10 milliliter because of the time constraint we have for the demo purpose. So we didn't add any other levels. And it's basically a peak controller, like proportional controller. And okay, and there's like intelligent water. What if like in the milliliter mode, like the water level is only 200 milliliters, but the user doesn't know the level, right? Because the tank will be outside. So you input like, for example, the main tank level has only 200 milliliter of water, and the user inputs 100 milliliter, 100 milliliter, 100 milliliter. So the result will be like it will automatically calculate the percentage of water in the tank, and it will automatically allocate like 60 milliliter, 60 milliliter, 60 milliliter all the locations. And
you anyway sense the water level in the tank, right? Which is displayed on the graphical schedule. Right?
Yeah.
User can, whenever he's allocating anything, he can just look at the level.
Yeah, he can. Yeah, he can. This thing also, but sometimes he won't be like.
In any case,
he wants this amount of water, because the opening screen is just the allocation thing.
And
So
you take into consideration that okay, some like washing it requires a minimum, laundry requires a minimum number of amount of water. If he's entering 100 ml of water, if you put lower, the washing machine won't run. Because it's not yet,
No, so the idea of the system is this is added on to the current system in the house. So if the rainwater tank by chance finishes and his allocation is not enough, it will tap from the main tank, but we couldn't simulate that. So it's just add-on to save electricity.
Let me ask you, why do you need the allocation? I didn't understand the concept. The tank is from the tank.
The reason there is an allocation is because, for example, assume the person he has a certain, for example, some athletes, they want to have certain amount of drinking water every day in their tanks. So
that is a different issue.
Yeah, I mean, for example, a person who does laundry every day can allocate this much of water for laundry and keep it, and he doesn't have to bother with the system again. So he can be guaranteed that if there is rain...
This is like prepaid or paid service.
Even now, right? I actually don't need to go and open the washing machine or anything.
It is
always connected to the washing machine. So I don't have to worry about that or.
And I look at this a different way. This is not a home-based system. If you consider the whole village, and you have a very big tank, then you need to allocate to different people.
It could be,
that is something
projected outward.
But if it's in a house, I don't know. I don't really digest the concept of why do we need allocation.
If you are saying that I need 100 ml of water, I come from a really long run, I say I'm not getting more water than.
No, the idea is that the 100 milliliter that you have allocated will come from the rainwater. So it's not tapping out from your electricity bill. For example, laundry is a task, it's a mundane task, and it consumes a lot of main water tank, water bill, because you're filling the washing machine again and again. So the idea is if it's raining, put this rainwater to good use by sending it all to laundry, so that you don't take anything from your main valve, and therefore you don't increase your water bill.
So why can't you just use the rainwater tank directly fill your main tank?
Because then again you're opening the main valve and the main meter will be running, right? So here it's a completely augmented system, but the idea is that you save money because it's free water, unlike the water you're taking from the government or whatever, because it's from the main line.
Precisely, then you shouldn't allocate at all. Just let it run out first.
I think in this case,
whoever wants to use it, whether it's for laundry or for drinking or for bathing, whatever, just let me run out first.
Yeah.
Then you worry about turning on the main
Yeah,
camera.
I still feel that you should, I mean, instead of saying laundry and all that, you could have said section 1, section 2.
Yes, you're right.
3.
You're right.
I don't know what that section is. It can be some people, ladies hostel there, boys hostel there, something else.
But I mean, the idea is that it can be projected out into any grand scale.
Yeah.
So we brought it from a small house perspective so that it's easier. And if you put section
I
1,
tell
2,
you,
3, it
in
will be
reality,
confusing.
people don't mix these two
Oh, okay.
for drinking and all that, because of the infectious diseases, all kinds of things. People really separate this out. Okay, continue. Yeah.
So
What's the pinch valve you were saying?
It's like it controls the water flow. So because it's counting the volume here,
Oh,
so basically, so it's allocating the amount of water.
What's the accuracy? Is it?
It's almost
yeah, we'll show at the end when the water is finished.
For drinking, it has allocated more than 100, so it will take a long time.
Oh, okay.
so there are 4.
1, 2, 3, 4.
Yeah, and then you push it through this, right?
Yeah.
Yeah. This is.
Oh, this is basically to close and open.
Yeah.
Oh, okay.
It's just the valve.
Oh, okay. I mean, that is created by you, not
Yeah.
bought, right?
Huh?
Yeah.
It's not
made
bought.
by us.
No,
Basically,
it's
Yeah, we made it.
Yeah,
you
Bend
bend,
it.
everything
you bend,
bend,
Yeah.
Oh, that's very simple. That's interesting.
And it's cheap. Basically, the idea is it's a cheap
Yeah.
system.
The only thing is that it is cheap. It don't work for long.
Wear and tear.
The wear and tear
It's very,
of
very
As you can see, like we
ingenious.
allocated 150 milliliters to this location. See, it's 150 milliliters of water allocated.
the accuracy is very close.
It's a very good design. Okay. I mean, don't take the word other way around. Very good.
Perhaps we brought it down to the house level. That could be prototyped. I mean, village level also would be difficult. That's the only reason.
Yeah, do away with the allocation.
So while it's allocating, you just.
But I think you want to really utilize, I mean, bring in certain concepts like these kinds of sensors and actuators. It's a very nice way of. Very good. Anything else? Yes. Yeah.
So I'll just explain how the heating mechanism in the display works.
Where is heating?
So this again happens inside this control tank. So what happens is we've managed to fit.
You bought what is all?
This is again, we bought. This is just a pipe here. We fitted everything, all this inside ourselves.
Is there a main pump somewhere?
There's no pump at all.
No pump.
Which is why we're just relying on water pressure to make them work. So
But it's always downward flow.
Yeah.
it's always downward flow. That's the only. That's the
Then there's no need to be at such a great height, right? I mean,
But thing is, we need,
considering the diameter of this, if it's a little bit smaller,
the thing is, we try with different varying lengths of pipes because of the moving motion of the valves. We need some pipe length to open, and when we close it again, there's not enough water pressure at times to accommodate the water flow. Which is why, as such, we've had to make a
Even now,
slightly higher
sometimes
height.
water flow is,
is,
less because there's not enough.
It's
so it
really a
moves
physical
slowly.
constraint that we have.
Sorry, did you make this or you?
Yeah.
Oh, this is just a PVC pipe like this. We bought,
No,
we
no.
bought the pipe and we
Whole
made it
thing,
ourselves.
everything.
We made the
That you
entire
should
thing.
highlight.
We made the entire thing, everything actually just except for the LCD.
So what all things going inside that?
Inside this is a PVC pipe with just covers. Inside is a thermistor, is a heating element with the level sensors. So there are 3 things simultaneously running inside this.
Okay.
So what happens is during the heating part, the water comes into this in sections of 50. It heats it up to a certain desired set point temperature, and then it outputs it to the third location. So at its simplest, it's a feedback loop.
Okay.
Right? There's a thermistor which checks the temperature of the water, is it heat or not, and then it compares with the desired.
So except the motor, LCD, CPU, PCB, you made everything.
Pretty much the entire thing. We've handled the house structures, everything.
Yeah, I mean, I'm not worried about high structure, but
Yeah,
these are all very interesting.
Yeah.
I have one question.
Sure.
Do you preset the amount of water going into the other tap, or is it that you measure it how much it comes?
We made it according to the allocation.
According to the
We've
allocation.
allocated an amount.
When you're transmitting the water, let's say,
Okay.
you have the 2 levels, right, 10 ml and
Yeah.
50 ml.
Right.
Do you transmit water in amounts of 10, or is it,
Depending on the allocation, like you say. So
Like there is like there is a 10 milliliter level. Like it will detect the water if the 10 milliliter will send a signal, and 50 milliliter also there is a signal. So if
For example,
like if you allocate 60, so in a program it automatically decides that it has to run one 50 milliliter loop and one 10 milliliter loop.
Exactly.
So when it runs the 50 milliliter loop, so when that counter tank is filling, until it reaches the 50 milliliter loop, this tank will be open. Soon as it reaches this tank will close. So it has 50 milliliter. So it will send out all the 50 milliliter to the location. Then it will run the 10 milliliter loop. It's like step like for loop.
User input that we've been.
It's kind of a sequence kind of as well. Yeah.
So essentially, that's what the heating mechanism is. Also, another part of this subsystem that we've had is this 7-segment display, which is a status indicator for the system. Essentially, we can program it in any way imaginable, but we've tried to indicate symbols to indicate when it's done heating, when it's not yet done heating, things like that. Alright, so what happens is in this procedure, as you can see, it's just a simple feedback loop. There's this desired set point, and until that set point is reached, the nichrome wire, which is the heating element, just keeps heating the water. And while that happens, the thermistor is constantly checking the temperature, which is inserted in. And once the temperature is reached, the power is cut off to the nichrome, and the heating.
Why did you think of buying? Why did you make it like that?
A couple of things include. In fact, you can probably just feel the water is warmer than this. It's warmer than that.
Cool, yeah.
You see? So that is the idea for making this essentially is, first of all, cost initiative. We didn't want to buying a heating system would be really expensive.
Is it available something of that kind?
There probably is the main sort of heating mechanisms available.
Okay.
The idea of making it is we can we just want the system to work with our
the motivation
standards basically.
Why do you need a 7-segment LED when you already have a graphical city?
The thing about this was this particular 7-segment here. What happened was this particular graphical is taking up a whole pick of its own, right? And so there's in fact right now there's we're already on the edge of the memory available for that pick to display some information. So we decided to use this 7-segment separately.
What is that for?
Yeah, that shows that it's waiting for a signal from the other
This
place.
is for you to understand.
For us, yeah.
But not for the user.
Not for the user. Not for the user. This is for maintenance purposes.
But there are other stuff like S and H to say when the water is hot. You know, the idea.
And when this counter tank is full, it will show full and
That's
E.
not for you.
Yeah, but the idea was essentially because this was taking up a lot of the memory with its different functions that we couldn't squeeze in more without sacrificing some of the essential functionality.
It's used mainly for maintenance. So when the maintenance guy comes, he can,
Just look
check it to see if the system is working correctly or not.
And also, if the tank is hot, now if there is, for example, kids in the house, the 7 display will be near the tank, and if it's etched, the parents will have told them, don't go near it because it's hot. So stuff like that.
And the moment parents say that, the kids will
Go to it.
Leak check has started.
Okay, show us a leak check. Yeah, so what happens in a leak check is a simple concept. What happens is it opens the main valve and it fills up all the pipes in the system and closes all the bottommost valves. So, and then what happens is it holds it in that position after this one closes it holds it in that position for a preset amount of time, and then after a while it will check is the water level the same as we left it before. I mean, if it is, there is no leak.
How much is the accuracy?
It's very accurate. So, for example, I will make a leak come out of here now, right? I'm simulating a leak, and so now this detector there is a leak and immediately empties all the water because there is a danger. So it's an instant drain kind of thing, and then once all the water is emptied in the GUI, so that when the user wakes up this morning, the leak it will say that there is a leak in the pipe.
That's very interesting. It's a nice concept.
So actually we were going to come to that in the end, but yeah. So maybe we'll just show the other stuff conceptually in the system. Basically, this is the entire system, but we'll just explain the other stuff.
So to continue with another feature that we've used is a USART communication from pick to pick. So what happens is we need information to be sent from both picks from one to the other, because input is happening on one and process to the other. So we've created sort of a simple language to communicate between the two microprocessors. What we've done is based on the simple concept of a master pick and a slave pick means sending and receiving information. So the master pick, what it does is any action that needs to be carried out, for example, water allocate or open lid, for example, is converted into an alphabetic letter. So A, B, C, whatever. Similarly, if any data has to be sent, for example, the number, the milliliter water, or the percentage value, that gets converted into an 8-bit number. So these two bits of information are sent through serial communication to 8-bit, where the information is decoded and the instruction is carried out at the right time. So essentially that is the system of communication that we've used. So to move on, we finally, I'll let Salman wrap up the graphic LCD and the touch screen.
Just to add on to what he said about the data communication, the idea is that one PIC is taking up the entire graphical LCD because there's so much of coding to do for that. So the other PIC has all the algorithms for the system. So the first PIC has to tell, hi, it's time to start the other thing, and he sends a certain amount of data in a certain language that we have coded, and then the coding basically starts. So I will explain the graphical LCD and the touch screen. The graphical LCD for this system is basically in 3 pages, I would say, 3 screens. There's a water allocation screen where you choose the bars to allocate the water, which we saw. Then there's the scheduler screen where the clock is running and you can see when the next allocation is, when the next leak check is. And then there's a system overview where you can see a picture of the tank as its current status, whether there's a leak in the pipes or not, whether there is what kind of allocations are given all over the house. The special features are that in the water allocation screen you have that bar which is easy to use, easy to understand, and you can immediately learn. Then in scheduler, whenever something happens, for example, if water allocation has started, there will be a message saying allocation has begun. So that message will be there. And then in the system overview, there's an auto refresh feature where it refreshes every 10 seconds after checking the whole system. So if, for example, between that 10 seconds there is a drop of water in the main tank, it will be updated. So there's an auto refresh feature. And there's of course graphics to show the tank image itself. So it's a very intuitive interface. And then the touch screen has 2 types of inputs. You have the standard touch where you can touch and pick, and there is the sliding gesture where you can have one-dimensional slide to scroll between screen to screen, somewhat like an iPad or an Android phone. But the reason is because it's a resistive touch screen, it's not so responsive, but we have tried to make it as accurate as possible. And the best part is there's instant transition. The user doesn't need to say, I'm going to change screens now, so switch to sliding feature. Or I'm going to touch something now, so switch to touch feature. There's an instant transition and there's auto masking of the other features. So if I'm going to slide, then all the touch inputs get masked and nothing else will get touched. It will only be recognized as a slide. So there's instant transition between those two. The only limitation is because if it was a capacitive touchscreen, it would work better. But we have used a resistive touchscreen because capacitive touchscreen is harder to program. Then the leak checking algorithm which we saw, basically once again I'll reiterate the idea. Suppose there is a tank and it has some water, and what we do is we fill in all the pipes in the system, and we set a preset amount of time for it to wait, and after time delay it will check. If the water level has dropped, there is a leak and it empties the system and goes into lockout. Otherwise it just empties the water in that pipe and agrees that there is no leaks and the system can go on. So it's a basic time delay based check. So our idea is to make the interface as simple as possible. Due to memory constraints, we wanted to add some more features like it will automatically recommend to the user, you've been drinking more water than you're using for laundry, why don't you allocate this much? But there was no space in the PIC to put it in, otherwise it would have been an additional feature. And priority allocations and stuff like that, but because of the memory constraints we couldn't do it. But other than that, this is our entire rainwater management system, and we're open to any questions.
And like you can see that we simulated a leak in pipes, right? So it says that there's leaks in the pipes in the system overview. You can see now that it's there.
Yeah, cool. Was it? Well done. Yes, we have a lot of Q&A along the way. So.
Yeah, that's very good. Okay. So I liked it because you try to use water as a theme and use the pipes and all that, and